Explain with the help of a diagram how plane polarized light can be produced by scattering of light from the sun. Two polarites P1 and P2 are placed with their path axis perpendicular to each other. Unpolarized light of intensity I is incident on P1. At third polarized P3 is kept between P1 and P2 such that its passes axis makes an angle of 45 degrees. With that of P1, calculate the intensity of light transmitted through P1, P2 and P3. We'll see this one. Okay, we'll see the diagram here. The diagram looks like this. Here the sun radiates will be falls in this direction. This is the incident light, unpolarized. When this sunlight falls on any water droplet, then it is a scattered light, it is polarized to the observer in the perpendicular direction. Okay, we'll see the explanation part here. Charges accelerating parallel to the double arrows do not radiate energy towards the observer. The radiation scattered by the molecules therefore is polarized or perpendicular to the plane of the figure. Okay, then the intensity of light transmitted by the first polarized is given by I1, which is equal to I divided by 2. Okay, when intensity of the light transmitted by the second polarized is given by, that is I2, which is equal to I1 cos square 45 degree. Cos square 45 degrees, which is equal to 1 by 2 times 1 by root 2 whole square, which is equal to this root square and square root will get cancelled. 1 by 2 into 1 by 4, it becomes 1 by 4. And the intensity of the light transmitted by the third polarized is given by, that is I3, which is equal to I2 cos square 45 degree, which is equal to 1 by 4 into under root of 1 by root 2 whole square. Again this will get cancelled. 1 by 4 into 1 by 2 is equal to 1 by 8. Okay. These are the intensity of the light transmitted through P1, P2 and P3. Second part here, or why cannot the phenomenon of interference be observed by eliminating two pinholes with two sodium lamps? Because two independent sources cannot be coherent or they are not coherent. B. Two monochromatic waves having displacement y1 a cos omega t and y2 a cos omega t plus 5 from two coherent sources interference to produce an interference pattern. Derive the expression for the resultant intensity and obtain the conditions for constructive and destructive interference. Okay, here we can say that is the part B question in the second case. B, that is y1 is equal to a times cos of omega t and y2 is equal to a cos of omega t plus 5. So resultant displacement is given by, that is y is equal to y1 plus y2, then y is equal to a cos of omega t plus a cos of omega t plus 5. Then we can write y is equal to 2 times a cos of 5 by 2 cos of omega t plus 5 by 2. The amplitude of the resultant displacement is, that is 2a cos of 5 by 2, and therefore the intensity at the point will be I is equal to 4 times I naught cos square of 5 by 2. Okay. For constructive interference, we can write this one as, that is 5 is equal to 0, plus or not 2 pi, plus or not 4 pi. And for the destructive inference, we can write the 5 value, that is equal to 5 is equal to plus or minus pi, plus or minus 3 pi, plus or minus 5 pi. Then the third condition here it is, two wavelengths of sodium light of 590 nanometer and 596 nanometer are used in turn to study the difference taking place at a single slit of aperture 2 into 10 to the power of minus 6 meter. If the distance between the slit and the screen is 1.5 meter, calculate separation between the position of the second maximum of diffraction pattern obtained in the two cases. Then we can see here, they can give the data here. This is equal to x1 is equal to, we know that x1 is equal to 2n plus 1 divided by 2 times lambda d divided by alpha. Okay. Then n is equal to 1. Then we can write this one as 3 by 2 times d by alpha times 590 nanometer lambda value. In case of x2, the x2 is equal to same data, that is 3 by 2 times d by alpha into 596 nanometer. And x2 minus x1 is equal to 3 by 2 times d by alpha into 596 minus 590 nano into 10 to the power of minus 9 meter. Okay, then we'll get the value 3 by 2 into 1.5 meter, that is 1.5 meter divided by 2 into 10 to the power of minus 6 into 596 minus 596 into 10 to the power of minus 9 meter. Then we will get the result, that is equal to 6.75 into 10 to the power of minus 3 meter, or we can write 6.75 of millimeters. In terms of meter, 10 to the power of minus 3, or in terms of millimeters, it is 6.75 millimeters.